Alright, so I got like 20 minutes before I gotta head up and head home. So, see what I can do on your homework. So we are tasked with graphing x squared minus 2x. So I'm just going to do some of the stuff I've been teaching you. I'm going to focus on my vertex. I'm going to use x equals opposite b over 2a. So a is 1, b is negative 2. I'm just going to plug into that. So opposite of a negative 2 is a positive 2, and that's going to be over twice a 1. I'm going to get 1. My vertex is at 1. So I put that smack dab in the middle of my table. All right? Now that I have x, I plug it back in to get y. 1 squared is 1. Take away 2 1s would be negative 1. Should be anyways. I would think it would be. Plot that point to the right one, fall one. This thing is going to open up. I'm going to plug in a 0. When I plug in a 0, oddly enough, I get a 0 back. That's great. Something to the right is a 2. By the way, line of symmetry. And using symmetry, I should get a 0 back. So there's my 3 key points. There's my parabola. Her domain is negative infinity to positive infinity. Her range has a low value of negative 1, high value of positive infinity. Moving on to number 2. Same deal, opposite b over 2a. So the x-coordinate of the vertex is going to be a negative 2 over twice a 1. This is going to be negative 1. If I plug a negative 1 in, I'm really tired here, by the way, but this should be 1 minus 2 minus another 2. That should be negative 3. 1, take away 2, take away 2. Yeah, that's negative 3. So the point back 1, fall 3, line of symmetry comes into play. Another point using axis symmetry, domain and range, it's all there. So I'm going to plug in a 0, and actually that becomes after negative 1. If I plug in a 0 here, this thing's going to spit back negative 2. So here's 0, negative 2. I know some kids don't like working with numbers, but if this point's on it, so is this point, and that point's at negative 2, negative 2. And there is my parabola. Same domain as all parabolas, negative infinity to infinity. Range would be negative 3 to positive infinity. They're actually pretty easy, aren't they? Oh, anything tricky about this one? We just got a negative and a negative. So again, we do opposite b over twice a. That's going to be 2 over negative 2, which is negative 1, just like the last one. Vertex goes in the middle. If I throw a negative 1 at this thing, it's going to return negative 1 plus 2, which is 1, plus 3, which is 4. So back 1, rise 4. This thing's going to open down, isn't it? It's got that negative symbol out front. Plug in a 0, 0, 0, 3. Oh, I forgot my line of symmetry. Now, if there's a point at 0, 3, there has to be a point at negative 2, 3. And there is my little bitty parabola. Same domain, negative infinity to positive infinity. The range is going to be 4 to negative infinity. The high value is 4. I said that backwards. Let me make sure I write it properly. The range is negative infinity to 4. Low to high. That's how we do all these. If you haven't caught on, by the way, the domain for all of these is negative infinity to infinity. That one's going to have a domain of negative infinity to infinity. This one has a domain of negative infinity to infinity. This one has a domain of negative infinity to infinity. They all do. So 3 more to go on the front. Opposite b over 2a is happening again. Negative 4 over twice a negative 1 is going to be a 2 when everything is said and done. If I plug in a 2, this is going to become negative 4. I'm going to add 8. That's going to take me to 4. I'm going to take away 3. That's 1. So the point 2, 1 exists on the graph. That's the vertex. It also happens to be where my line of symmetry is. I don't know that I want to plug a 0 in, but it looks nice. If I plug in a 0, this thing's going to have to spit back negative 3. And if this point exists, so does this one. So the point 4, negative 3 exists as well. And don't be lazy and not draw the parabola. I swear I will take off points for those of you that just do your 3 points It isn't IXL where it draws it for you. Just being lazy. Range on this one, the high value is 1. The low value is negative infinity. Don't get those backwards. Easy to do. Yay, more opposite b over 2a. Negative 4 over twice the negative 1 should be 2. If I plug a 2 in, this thing is exactly like the last one with a different number, isn't it? It's going to spit back a... I'm thinking something else. But it is exactly like the last one with the exception on the end. If I plug in a 2, I'm going to have negative 4 plus 8, which is 4, take away 2, which is 2. So 2, 2 exists. Line of symmetry. I'm going to plug in my 0. If I plug in a 0 into this thing, it has to return negative 2. Using symmetry, right there, 4, 0. Or sorry, I plugged in a 0. I was supposed to plot negative 2. Using symmetry right here, I should probably go home. I am obviously too tired to do this. And there is my parabola. Her range is negative infinity to 2, including 2. Yeah, I'll try and do 7 and 8. All right, so to find x-intercepts of an equation, you replace y with 0. To find the y-intercept, you replace x with 0. So you're tasked with finding the x and y-intercepts of the equations below. That's all it says. So cool. X-intercept up first. My y becomes a 0. 4x plus 2 zeros is 8. 4x is 8, and my x-intercept is equal to 2. For my y-intercept, I let the x's be 0. And I end up with a y-intercept equal to 4. Boy, that one was easy, wasn't it? You have to graph it or anything. It was the workup problem for number 8, which is a god-awful problem, if I remember right. It's actually not that bad, but to y'all it will seem that way. So I'm going to go after the x-intercept first. I'm going to let my y value be 0. So this y becomes a 0. X minus 4 all squared plus 0 plus 3 squared is 9. Now 0 plus 3 is 3. 3 squared is 9. So x minus 4 all squared plus 9 is 9. Subtract 9, I get a 0. The opposite of squaring is a square root symbol. The square root counteracts the square. The square root of 0 is 0. And I get that x is 4. So there's my x-intercept. I got to do the same process to find the y-intercept. So on a y-intercept, I let x equal 0. So I put a 0 here. And I'm going to get something funky here. That's something you actually know how to work with now. It's just going to be imaginary. 0 minus 4 squared is 16. I'm going to take away 16. 9 minus 16, I don't know why I wrote that out, is negative 7. I'm going to counteract squaring with square rooting. And I have that y plus 3 is equal to plus or minus the imaginary root of 7. It actually does have 2 intercepts. They're just imaginary. That's all they are. I subtract my 3. I write this in complex form, a plus or minus bi. Negative 3 plus I root 7, or negative 3 minus I root 7. Now the reality is there is no real y-intercept. Because those are imaginary, right? So I'm going to stop this video here so that I can go home and get some rest. So I'll probably record a little bit tomorrow. You guys will probably all watch this Tuesday or Wednesday night before it's due. I don't know. You do you.